You are sitting still as you listen to this. Your body is warm. The room around you feels stable, predictable, quiet. Air moves gently in and out of your lungs. Heat lingers in your skin. Nothing feels urgent. It is easy to assume that warmth is the natural state of things. That energy is abundant. That motion, activity, and change are the defaults of reality. But that assumption is wrong. The warmth you feel is not a property of the universe. It is a temporary imbalance, a rare exception in a system that is relentlessly moving in the opposite direction. Every second, without sound or resistance, the universe is losing something fundamental. Not matter, not space, but the ability to do anything at all. This loss is not dramatic. It does not arrive as an explosion or a collapse. It arrives as silence, as uniformity, as the slow erasure of difference. The unsettling part is not that this process will happen in the distant future. It is that it is happening now. Every atom in your body participates in it. Every thought you have depends on resisting it. The universe is getting colder, not in the everyday sense of temperature, but in a deeper, more absolute way. A way that speaks to the fate of time, motion, and existence itself. The question is not whether this cooling will continue. The question is what remains when it is complete. And that is what you are about to descend into. Warmth feels natural because you live inside an exception. You are surrounded by warmth, so it feels ordinary. But warmth is not a baseline condition of reality. It only exists when energy is unevenly distributed, when differences still survive. Your environment feels alive precisely because it is borrowing from a limited reserve. The universe, as a whole, does not favor warmth. It tolerates it briefly, then removes it. What you interpret as comfort is, in physical terms, a fragile imbalance. Heat is not something the universe produces effortlessly. It is something that exists only when conditions are carefully misaligned. The moment those conditions relax, warmth dissolves. This is why heat always flows away from where it is concentrated, never toward it. There is no preference involved. It is not a tendency. It is a rule. You live inside a pocket where this rule has not yet finished its work. Energy still arrives faster than it escapes. The sun floods your planet with high-quality energy, and Earth radiates it back more slowly, at lower intensity. That delay is everything. It is what keeps oceans liquid, air moving, and your body functioning. But it is not permanent. It is a temporary bottleneck in a much larger process. If you remove that imbalance, warmth does not fight to remain. It vanishes without resistance. A room left unheated does not argue with the cold. It simply equalizes. The same principle applies at every scale, from molecules to galaxies. Wherever warmth exists, it is already on borrowed time. This is why warmth feels so natural to you. You have never experienced a universe without it. Every sensation, every memory, every moment of awareness you have ever known has occurred inside this energetic exception. Your intuition is shaped by a phase of reality that is statistically rare and cosmically brief. From the perspective of the universe as a whole, your environment is not normal. It is extravagant. It is a place where energy gradients still persist, where differences have not yet been erased. The fact that you can feel warmth at all means the universe has not finished doing what it is structured to do. And that is the unsettling part. Warmth is not being taken from you by some external force. It is being removed by the same rules that allow it to exist in the first place. The conditions that make your world feel alive are inseparable from the process that is quietly undoing them. You are not witnessing the universe at rest. You are witnessing it mid-transition, passing through a narrow window where imbalance still survives. Everything you recognize as normal exists only inside that window. Temperature is not what you think it is. You think of temperature as a property of objects. In reality, it is a measure of disorder in motion. Heat is movement without coordination, energy spread across countless microscopic paths. When temperature drops, it is not just cooling. It is motion becoming less available, less expressive, less capable of change. What you feel as warmth is not a substance filling a space. It is a statistical condition. Billions of particles moving in many directions, colliding, transferring energy in ways that cannot be fully reversed. Temperature is not about how much energy exists, but about how freely that energy can move and redistribute itself. Two systems can contain the same total energy and feel completely different. One can be hot and alive with motion. The other can be cold and inert. This distinction matters because cooling does not mean energy disappears. It means energy becomes trapped in forms that can no longer do useful work. Motion narrows, pathways close, possibilities shrink. As temperature drops, fewer configurations remain accessible. The system still exists, but its freedom does not. You experience this intuitively without realizing it. Cold objects feel rigid. Cold environments resist change. Processes slow down. Reactions that once happened spontaneously require effort or fail entirely. This is not because nature becomes hostile, but because motion has lost options. The universe is not removing energy. It is removing flexibility. At a fundamental level, temperature tells you how many futures are still open. High temperature means many microscopic arrangements are possible. Low temperature means most of those arrangements are already ruled out. The system is constrained, not destroyed. It has settled into fewer ways of being. As the universe cools, this narrowing happens everywhere at once. Radiation stretches, particle interactions become rarer. Even time, as you experience it, becomes less eventful. Not because clocks stop, but because fewer irreversible changes occur to mark the passage from one moment to the next. This reframes what cooling truly means. It is not the approach of ice or darkness. It is the gradual loss of options. The universe is not becoming hostile to motion. It is becoming indifferent to it. Motion that once produced consequences begins to repeat without effect. You live at a temperature where countless transformations remain possible. Chemistry still rearranges matter. Heat still flows. Structures still emerge and dissolve. But this is not guaranteed by existence itself. It is guaranteed only by the temporary abundance of accessible motion. As temperature continues to fall, the universe does not shut down. It simplifies. And in that simplification, the richness you associate with reality quietly thins out. The universe is not cooling down locally, but globally. A cooling cup of coffee loses heat to its surroundings. The universe has no surroundings. When it cools, there is nowhere for the heat to go. Instead, energy spreads thinner across expanding space, diluting its ability to interact. Cooling becomes a geometric consequence of existence itself. This distinction is easy to miss because your everyday experience of cooling always involves transfer. Something warm gives energy to something cooler. Balance is restored by movement. But the universe is not a container inside a larger room. There is no external reservoir waiting to absorb its heat. When the universe cools, nothing receives what is lost. What actually happens is more subtle and more unsettling. Space itself expands. And as it does, the same amount of energy occupies a larger volume. Photons stretch, their wavelengths lengthen, their energy drops, not because it was taken, but because the stage they exist on has grown. The universe cools not by losing energy, but by making energy less effective. This is why cosmic cooling is irreversible. You cannot compress the universe back into a smaller space to recover what was lost. Once energy has been diluted by expansion, it cannot be recollected into the same concentrated forms. The process does not violate conservation laws. Energy remains accounted for. What vanishes is usefulness. You can think of this as a fading of influence. Early in the universe, energy interactions were unavoidable. Particles collided constantly. Radiation shaped structure. Today, vast regions of space are so empty that interactions are rare events. Cooling is not a sudden change in temperature. It is the gradual retreat of causality. As expansion continues, distances grow faster than signals can compensate. Light takes longer to reach anything. Forces weaken in practice, even if not in principle. The universe becomes quieter, not because it is empty, but because it is spread too thin to sustain conversation between its parts. This global cooling also explains why no region is exempt. You cannot isolate a pocket of the universe and keep it warm indefinitely. Every structure that exists does so against the backdrop of expansion. Stars, galaxies, even bound systems operate under a ceiling imposed by the geometry of space itself. The unsettling implication is that cooling is not something happening to the universe. It is something the universe is doing by existing the way it does. Expansion is not a background detail. It is the mechanism through which energy loses its voice. You are not living in a universe that is cooling like an object. You are living in a universe whose very shape guarantees that warmth, interaction, and intensity are temporary features of its history. Expansion quietly steals energy. From everything, space is not empty and passive. As it expands, it stretches the energy within it. Light loses intensity. Radiation shifts to lower frequencies. Nothing breaks. Nothing explodes. Energy simply becomes less usable, less concentrated, less meaningful. You are used to thinking of energy loss as something dramatic, a collision, a release, a visible change. But cosmic expansion does not announce itself. It works without friction, without sound, without resistance. As space grows, every wave of light traveling through it is elongated. Its wavelength increases. Its energy decreases. No force acts against it. No law is violated. The energy has not been destroyed. It has been diluted by geometry. This matters because energy is only useful when it can produce change. High-frequency radiation interacts strongly. It can heat matter, drive reactions, alter structure. As frequencies drop, interactions become rarer and weaker. The universe does not remove energy from existence. It removes its ability to matter. This process affects everything, everywhere, all at once. The light from distant galaxies arrives stretched, reddened, weakened by the expansion it has crossed. What reaches you is not what was emitted. It is a degraded message, altered not by obstacles, but by the growth of space itself. Every signal you receive from the cosmos has already paid this cost. Even bound systems are not completely immune. While gravity can resist expansion locally, it cannot reverse the global trend. The background in which all structures exist continues to stretch. Over long timescales, even the most stable configurations must contend with a universe that is steadily making energy harder to concentrate. This is why expansion is more unsettling than explosion. An explosion is finite. It ends, Expansion does not. It imposes a permanent tax on energy, paid continuously and without exception. Every second that passes, energy becomes slightly less capable of doing work than it was the second before. You do not notice this because your timescale is short and your environment is artificially maintained. Stars are still burning. Heat still flows. But the mechanism responsible for that activity is already eroding the conditions that allow it. Expansion does not target objects. It targets potential. It does not destroy structures directly. It undermines the energetic differences that make structures possible in the first place. The universe is not running out of energy. It is running out of ways to use it. And expansion is the quiet, persistent reason why. Entropy is not chaos, but final calm. You may imagine entropy as disorder or mess. That image is misleading. Maximum entropy is not chaos. It is stillness, a state where nothing interesting can happen because everything is already the same. Chaos is active. It is loud. It is full of collisions and rearrangements. Entropy, at its maximum, is none of these things. It is the absence of preference, a condition where every possible difference has already been erased. When entropy increases, the universe is not becoming more violent. It is becoming more even. You can see a small version of this in everyday experience. When you drop a dye into water, it spreads until the color is uniform. At that point, nothing dramatic happens. The motion continues at the microscopic level, but no visible change remains. The system has reached a state where further motion produces no new outcomes. That is not chaos. That is completion. In physics, entropy measures how many microscopic arrangements correspond to the same macroscopic state. High entropy means there are many ways for a system to look the same. When everything is already evenly distributed, almost every motion simply recreates the same condition. The system becomes statistically stuck, not physically frozen, but functionally static. This is why entropy increase defines an arrow of time. You remember the past because it contained fewer possible arrangements. The future contains more, but those possibilities converge towards sameness. As entropy rises, the universe loses distinguishable moments. Events blur into repetition. The unsettling implication is that entropy does not end motion. Particles can still move forever. What ends is significance. Motion stops producing difference. Change stops leaving traces. Cause and effect become trivial because effects no longer accumulate into anything new. A universe at maximum entropy is not dead in the dramatic sense. It is exhausted. All gradients have flattened. All temperatures have equalized. All energy has settled into forms that cannot be reorganized into structure. Nothing prevents motion, but nothing rewards it either. From your perspective, entropy feels like decay. But decay is only visible while contrast exists. When contrast is gone, there is nothing left to decay. The universe does not collapse into chaos. It relaxes into uniformity. You live far from that state. Your thoughts, your memories, your body, all depend on low entropy conditions. You require imbalance to function. The fact that you can observe entropy at all means the universe has not yet reached its calm, but the direction is fixed. Entropy does not rush. It does not hesitate. It simply increases, guiding the universe toward a final condition where difference no longer has meaning and nothing remains that could be called interesting. Time only flows because things are unequal. You experience time because change is possible. Change requires gradients, hot and cold, dense and sparse, past and future. As these differences fade, time does not stop suddenly. It thins. it loses direction. Eventually, it becomes indistinguishable from nothing happening. You do not perceive time directly, you infer it from change. A sound begins and ends, a shadow moves, a memory replaces the present. Each of these depends on a symmetry. Something must be different from something else for time to leave a trace. Without difference, there is no sequence to observe. In physics, time's arrow is not imposed by clocks or equations. It emerges from entropy. Processes that increase entropy define what you call forward. Ice melts. Heat spreads. Structures decay into simpler states. These events are not just things that happen in time. They are what make time meaningful in the first place. Imagine a universe where nothing changes in any observable way. Particles may still move, but every configuration instantly resembles the last. No process leaves evidence. In such a universe, asking how much time has passed becomes meaningless. There are no markers to separate before from after. Duration loses its grip. As energy gradients flatten, this is the direction reality moves toward. Not a sudden halt, but a gradual loss of temporal texture. Fewer events stand out. Fewer irreversible processes occur. The universe does not freeze. It repeats itself so thoroughly that repetition becomes indistinguishable from stasis. This is why the cooling of the universe is inseparable from the weakening of time. Lower temperatures mean fewer accessible transitions. Reactions stall. Decays stretch out. Even change that does occur fails to cascade into something new. Time still exists mathematically, but it stops doing anything interesting. Your own experience of time is tightly bound to imbalance. Your thoughts require chemical gradients. Your memories require irreversible changes in neural structure. Your sense of flow depends on a continuous supply of energetic difference. Without that supply, consciousness itself cannot register succession. The unsettling implication is that time is not a fundamental background that will always be there. It is a feature of a universe far from equilibrium. As equilibrium approaches, time does not end. It fades in relevance. The future implied by this is not one where clocks stop ticking. It is one where ticking no longer signifies anything. Moments stop accumulating into history. Events stop building toward outcomes. You live in a universe where inequality still survives. That is why time feels rich, directional, and full. But that richness is conditional. Time flows only because the universe has not yet finished becoming equal. The early universe was hot for a reason. The universe began in a state of extreme concentration. Energy was packed tightly, violently uneven. That imbalance allowed structure, stars, chemistry, and eventually thought. Cooling is not a failure of that beginning. It is the unavoidable cost of it. In the earliest moments, there was no room for neutrality. Energy densities were so high that interactions were unavoidable. Particles collided constantly. Forces that are now distinct behaved as one. Nothing was isolated. Everything influenced everything else. This was not a gentle warmth. It was a condition where difference dominated every scale of existence. That initial heat is often described as a starting temperature, but that framing misses the point. What mattered was not heat itself, but concentration. Energy had not yet been spread thin across space. It was confined, compressed, forced into interaction. This made change inevitable. Structure was not an exception. It was a consequence. As the universe expanded, that concentration began to relax. Expansion did not erase energy, but it gave it room to disperse. Interactions became less frequent. Forces separated. Matter cooled enough to form stable particles, then atoms, then simple structures. Each step toward complexity depended on energy still being unevenly distributed. Stars could only ignite because matter clumped instead of smoothing out immediately. Chemistry could only emerge because temperatures dropped into a narrow window where bonds could form without being instantly destroyed. Thought itself required a balance between rigidity and motion, a condition made possible only because cooling had not yet gone too far. But every one of these developments carried a cost. The same expansion that allowed structure also guaranteed its eventual decline. Each interaction that produced order also increased entropy elsewhere. The universe paid for complexity by making uniformity more likely in the long run. This is why cooling should not be interpreted as decay or loss. It is bookkeeping. The universe began far from equilibrium. Everything that followed was a way of spending that initial imbalance. Stars, planets, life, and awareness are not deviations from thermodynamics. They are expressions of it. The unsettling realization is that the early heat was not a gift meant to last. It was a condition meant to be resolved. The universe did not start hot, so it could remain active forever. It started hot, so it could change. Cooling is the signature of that change progressing toward completion. What you inhabit now is not the natural state of the universe, but a transitional phase between extreme concentration and near-perfect uniformity. You exist because the beginning was hot enough to allow difference, and because the universe has not yet finished erasing that difference. The same origin that made your existence possible also set a limit on how long such conditions can persist. Stars exist only by burning through the difference. A star is not a stable object. It is a controlled leak. It shines by converting concentrated energy into dispersed radiation. Every second it exists, it accelerates the universe toward uniformity. Stars do not fight the cooling. They assist it. What appears to you as a steady, reliable source of light is, in physical terms, a temporary imbalance being resolved. A star exists only because gravity has forced matter into a dense configuration while nuclear forces resist complete collapse. That tension creates a narrow channel through which energy escapes. The glow you see is the universe equalizing itself, one photon at a time. Inside a star, energy begins in a highly ordered form. Mass is packed tightly. Nuclear reactions convert that mass into energy that moves outward, from hot core to cooler surface, then into colder space. Each step spreads energy across a wider region. Nothing is preserved in its original state. The star survives only by losing what made it special. This is why stars have lifetimes. The fuel they burn is not optional. It is the price of maintaining structure against collapse. When the difference between core and surroundings diminishes, the star cannot remain as it is. It expands, sheds mass, or collapses into something simpler. The universe does not remove stars. Stars exhaust the conditions that allow them to exist. From a cosmic perspective, stars are engines of entropy production. They take concentrated matter and convert it into low-energy radiation that disperses into space. This radiation rarely returns to form new structure. Most of it drifts, stretched by expansion, becoming part of the background that can no longer drive change. You rely on stars for nearly everything. The warmth on your skin, the chemistry in your body, even the heavy elements that make complex matter possible, all come from stellar processes. But this reliance hides the deeper role stars play. They are not building the future. They are spending the past. Every star that shines makes the universe slightly more uniform than it was before, not dramatically, not noticeably, but irreversibly. The light that leaves a star does not come back. It does not reassemble into the same gradients. It carries difference outward and lets it fade. Stars feel like symbols of permanence because their timescales dwarf your own. But permanence is an illusion created by scale. Given enough time, every star completes its task. It erases the very imbalance that allowed it to exist. Stars do not oppose the cooling of the universe. They are one of its most effective mechanisms. Life is a temporary rebellion against equilibrium. Your body maintains warmth by exporting disorder outward. You survive by increasing entropy elsewhere. Life does not escape the universal trend. It rides it briefly, like a ripple on a flattening surface. Existence itself is thermodynamically expensive. Every living system is an open system. You take in low entropy energy and release it in a more disordered form. Food enters structured and concentrated. Heat leaves dispersed and diffuse. This exchange is not a side effect of life. It is the definition of it. The moment a system can no longer export entropy, it stops being alive. This is why life requires gradients. A difference in temperature, chemical potential, or radiation must exist between a system and its environment. Without that difference, metabolism has nothing to work with. No process can proceed. Life does not create order from nothing. It borrows order by paying with greater disorder elsewhere. From a distance, life looks like a violation of the universe's tendency toward uniformity. Complex structures emerge, information accumulates, patterns persist. But this appearance is misleading. Life is not a reversal of entropy. It is a localized acceleration of it. By building intricate structures, life increases the total entropy of the universe faster than if matter were left alone. You experience this as growth, thought, and awareness, but underneath, it is accounting. Every movement you make increases the disorder of your surroundings. Every thought depends on irreversible chemical changes in your brain. Consciousness itself is a thermodynamic process that cannot be undone without erasing the system that produced it. This is why life cannot persist indefinitely in a cooling universe. As energy gradients weaken, the cost of maintaining structure rises. Eventually, the energy required to sustain metabolism exceeds what the environment can supply. Life does not fail because it is fragile. It fails because the universe becomes too uniform to support it. The unsettling implication is that life is not a stable feature of reality. It is a phase, a brief period where energy differences are large enough to allow self-maintaining systems to exist. When those differences disappear, life does not migrate elsewhere. It dissolves. You are not separate from this process. Your sense of self, your continuity, your memories are all maintained by constant energy expenditure. You feel permanent because the flow has not stopped yet. Life is not standing against equilibrium. It is moving with it, momentarily shaping the descent. When the slope flattens completely, there is no place left for life to stand. The cosmic background is a memory, not a signal. The faint radiation filling space is not noise. It is the afterimage of a hotter universe. As it cools further, that memory stretches thinner, quieter, less informative. Eventually, even this echo fades into indistinguishability. What surrounds you is not an active broadcast. It is a fossil. The cosmic background does not originate from stars, galaxies, or ongoing processes. It comes from a time when the universe itself was hot enough to glow. When matter and radiation were inseparable, light could not travel freely. The moment they parted, that light was released, and it has been traveling ever since. You receive it now as a whisper because the universe has expanded around it. The radiation has not weakened due to distance alone. It has been stretched by space itself. Each wave elongated, each photon carrying less energy than it once did. What was once blinding heat has become barely detectable warmth, spread uniformly in all directions. This background is often described as a signal, but that framing is misleading. Signals are messages meant to be interpreted. This radiation carries no intention. It does not update, it does not change. It tells you only that the universe used to be different. It is not evidence of activity, it is evidence of exhaustion in progress. As cooling continues, even this memory loses structure. Differences within the background smooth out. Subtle variations fade. The information it contains becomes harder to extract than impossible. The universe does not erase its past violently. It allows it to blur until nothing distinct remains. There will come a time when no observer could infer the hot beginning from the radiation that remains. Not because the beginning did not happen, but because the universe has expanded enough to dilute its trace beyond recognition. History does not end. It becomes inaccessible. This has unsettling implications for knowledge itself. What you know about the universe depends on surviving asymmetries, patterns in radiation, clumps of matter, contrasts that encode information. As those contrasts vanish, the universe does not become mysterious. It becomes unreadable. The cosmic background is a reminder that information, like energy, is subject to thermodynamics. It can disperse, it can fade, it can become so evenly distributed that it no longer distinguishes one possibility from another. You exist at a moment when the universe still remembers itself clearly enough to be studied. That clarity is not guaranteed. The background you measure today is already quieter than it once was. It is moving steadily toward silence, not because something is destroying it, but because nothing is preserving it. When the memory finally blends completely into uniformity, the universe will still exist, but it will no longer tell its story. Cooling does not end structures, it prevents new ones. The most disturbing consequence is not destruction. Galaxies can persist for unimaginable lengths of time. The problem is creation. As energy differences vanish, nothing new can form. The universe becomes a museum that no longer admits exhibits. It is natural to imagine the future of the universe as one of collapse or ruin, but cooling does not act like a catastrophe. Existing structures are remarkably resilient. Stars can orbit for billions of years. Galaxies can drift intact across expanding space. Even after active processes slow, what has already formed may remain, suspended in a kind of cosmic inertia. The deeper loss is generative. Creation requires gradients. To form something new, matter must move from a state of higher potential to lower potential. Energy must flow. As cooling progresses, those pathways close, not because forces disappear, but because there is no longer enough difference to drive change in meaningful ways. Star formation is a clear example. New stars are born only when clouds of gas collapse under gravity, releasing energy as heat and radiation. That process depends on surrounding space being cooler than the collapsing region. As the universe cools and matter becomes more diffuse, such collapses become rarer, then impossible. The gas does not vanish. It simply lacks the contrast needed to reorganize. The same principle applies to every level of structure. Chemical reactions require energy differences. Geological processes require heat gradients. Biological evolution requires environmental variability. remove the gradients, and processes stall without breaking. This is why cooling leads not to destruction, but to stasis. The universe does not erase what exists. It stops adding to it. Over time, novelty becomes statistically impossible. Everything that can happen has already happened, not because it was forced, but because nothing remains to push reality into new configurations. The museum analogy is precise. Objects remain preserved, but untouched. Displays never change. No new artifacts arrive. Motion continues in trivial ways, but history stops accumulating. This future is not empty. It is overcomplete, full of matter, energy, and time, yet devoid of meaningful progression. Structures persist without purpose. Processes repeat without consequence. You live at a moment when the universe is still creative. New stars ignite. New structures form. New patterns emerge. That creativity depends on energy differences that are already diminishing. Cooling does not threaten what exists now. It threatens what could exist next. And that is a subtler, more absolute kind of ending. Black holes delay the inevitable, they do not stop it. Even the densest objects are not exempt. Black holes radiate, slowly leaking their mass into space. They are not eternal prisons of energy. They are long-term contributors to cosmic uniformity. Nothing resists forever. Black holes appear, at first glance, to be exceptions to every rule you have encountered so far. They trap matter. They seal energy behind horizons. They seem to halt the spread, concentrating mass so completely that nothing escapes. In a cooling universe, they look like fortresses against dilution. But that impression is temporary. Black holes do not violate thermodynamics. They obey it in a more patient way. Over immense spans of time, they emit radiation. This process is not violent. It is not visible in any practical sense. It is so slow that on human timescales, it might as well not exist, but on cosmic timescales, it is decisive. This radiation carries energy away from the black hole, reducing its mass, not abruptly, not catastrophically, gradually, relentlessly. The densest objects in the universe are not exempt from the rule that concentrated energy spreads outward. They simply pay the cost more slowly than anything else. What makes this unsettling is not the mechanism itself, but what it implies. If even black holes cannot permanently hold onto energy, then nothing can. There is no final container, no ultimate archive where difference can be stored indefinitely. Every attempt at preservation is temporary. Black holes do not reverse cooling. They postpone it. They take energy that would have dispersed earlier and delay its dilution across space. But delay is not resistance. The radiation they emit joins the background, stretched by expansion, becoming ever less capable of interaction. Eventually, even the last black hole fades into low-energy uniformity. This means the universe has no permanent refuges from equilibrium. Complexity can hide for a time, but it cannot remain hidden forever. The most extreme structures serve the same endpoint as stars, just on longer schedules. When black holes finally evaporate, they do not leave ruins or remnants. They leave absence. A space where something once delayed the inevitable and then quietly stopped doing so. You might expect the end of such objects to mark a dramatic transition. It does not. The universe barely notices. By the time the last black hole disappears, there is already so little left for it to influence that its absence changes nothing. Black holes are not failures of the cooling universe. They are confirmations of it. Even at its most extreme, concentration only slows the march toward sameness. It never stops it. Motion, without purpose, becomes meaningless. Particles will continue to exist. They may still move. But motion without gradients has no consequence. Collisions stop changing outcomes. Events stop producing history. Action becomes indistinguishable from inaction. It is tempting to imagine the far future of the universe as completely static. That intuition is wrong. Motion does not end. Particles do not freeze into place. They continue to drift, to pass through one another's influence, to follow trajectories dictated by the laws that still apply. What disappears is not movement, but significance. In your experience, motion matters because it leads somewhere. A collision produces heat. A reaction produces a new substance. An action leaves a trace that alters what comes next. These outcomes depend on imbalance. Energy must be able to flow from one state to another in a way that changes the overall configuration of the system. As gradients vanish, motion loses this capacity. Collisions still occur, but they do not accumulate into anything new. Particles scatter, but the result is statistically identical to what existed before. The universe continues to evolve in a technical sense, but it stops progressing in any meaningful one. This is the distinction between dynamics and history. Dynamics can persist forever. History cannot. History requires that events make a difference. It requires that the universe remembers what has happened by being changed by it. In a high entropy state, motion no longer writes memory into reality. You can imagine this as a perfect shuffle. Cards are still being moved, rearranged, and exchanged, but every arrangement is indistinguishable from every other. No sequence leads to novelty. No outcome excludes another. Time passes, but nothing accumulates. This is why a universe at equilibrium is not described as dead, but as complete. Nothing prevents motion. Nothing forbids interaction. There is simply no remaining asymmetry for motion to exploit. Without gradients, cause and effect flatten into repetition. From within such a universe, asking what happens next becomes an empty question. Whatever happens has already happened in every statistically relevant way. Motion ceases to be a driver of change and becomes a background hum with no direction. You live in a universe where motion still matters, where actions still carve pathways into the future. That condition depends entirely on imbalance that is already fading. When the universe finally reaches a state where motion produces no lasting difference, existence does not end. Meaning does. And the laws of physics, unchanged, continue to operate in a reality where nothing they govern can lead anywhere new. A cold universe is not frozen. It is exhausted. This future is not icy or dramatic. It is quiet. No engines fail, no clocks break. There is simply nothing left that can be used to make something else happen. When you imagine cold, you imagine stillness, ice, rigidity, a lack of motion. But the cold future of the universe does not resemble a frozen landscape. Motion continues. Particles still move. Fields still fluctuate. What disappears is the capacity for motion to accomplish anything. Exhaustion is a better word than freezing. A system is exhausted when it has spent every resource that allowed change. In the universe, that resource is usable energy. Not energy in the abstract sense, but energy that can be directed, transformed, or concentrated to produce new outcomes. In an exhausted universe, nothing breaks because nothing is being stressed. No engines fail because there are no engines left to run. No clocks stop because there is nothing meaningful left for them to measure. Processes continue mathematically, but they no longer generate distinction between states. This is why the end state of cosmic cooling is so difficult to visualize. It lacks the markers you associate with endings. There is no final moment, no visible transition, just the gradual removal of opportunities. Each change becomes slightly less capable of leading to another change. Consider how fatigue works in living systems. Exhaustion does not arrive as a sudden shutdown. It arrives as diminished capacity. Movements require more effort, responses slow. Eventually, activity becomes possible only in trivial ways. The universe follows a similar pattern, but without awareness. As gradients flatten, reactions that once occurred spontaneously become impossible. Not forbidden, but unsupported. There is no longer enough contrast to push matter into new arrangements. Everything that happens simply maintains the status quo. This does not violate any law. In fact, it is the natural outcome of those laws. The universe is not failing. It is completing its thermodynamic trajectory. The unsettling part is that this exhaustion does not spare complexity. Intelligence, memory, structure, and meaning all require access to usable energy. When that access disappears, these phenomena do not decay dramatically. They become unsustainable. You live in a universe that still has reserves. That is why change feels natural and inevitable. But that feeling is temporary. The future is not one of catastrophe, but of fulfillment. A state where the universe has done everything it can do. When nothing remains that can be used to make something else happen, existence does not stop. It simply has nothing left to say. Time becomes a concept without application. When nothing changes, time has no markers. Before and after lose distinction. Duration loses meaning. Not because time ends, but because it no longer matters. You are accustomed to time announcing itself through difference. A sound begins and fades, light shifts across a surface, a memory replaces anticipation. Each of these tells you that something has happened and that something else will follow. Time, as you live it, is inseparable from sequence. It exists because the universe still distinguishes one state from another. But time is not a substance flowing independently of events. It is a measure of transformation. When transformations become rare, trivial, or indistinguishable, time does not disappear. It becomes uninformative. It loses its role as an organizer of experience. In a cooling universe approaching equilibrium, change still occurs in principle. Particles move, fields fluctuate, but these motions no longer accumulate into anything new. They do not carve irreversible paths from past to future. They circle endlessly through statistically identical states. Without accumulation, there is no history. Without history, time has nothing to order. This exposes a quiet truth. The arrow of time you rely on is not guaranteed by the equations of physics. At the deepest level, most fundamental laws are time-symmetric. They do not care which direction you label as forward. What gives time its direction is entropy. Processes that increase entropy define what you call the future. When entropy stops increasing in any meaningful way, the arrow loses its sharpness. Imagine a clock in such a universe. It could still tick. Its internal components could still move. But each tick would be indistinguishable from the last. The clock would not be wrong. It would simply be irrelevant. Measuring duration only matters when duration separates different conditions. When every moment resembles every other, measurement becomes ceremonial. This is why time does not need to end to lose significance. Endings imply an event, an interruption, a boundary. But the loss of time's meaning is not an event. It is a thinning, a gradual erosion of contrast between moments until the distinction collapses under its own redundancy. Your own awareness is built on temporal structure. Thought unfolds in sequence. Memory depends on irreversible changes in physical states. Identity relies on continuity across difference. In a universe where difference no longer accumulates, these foundations cannot operate. Not because something blocks them, but because nothing supports them. The unsettling implication is that time is not a permanent backdrop to reality. It is a phase-dependent feature. It emerges when the universe is far from equilibrium and fades as equilibrium is approached. The universe does not carry time with it forever. It generates time when conditions allow and relinquishes it when they do not. From within such a future, the question of how long something has existed loses coherence. There is no meaningful answer, because existence is no longer punctuated by events. Without punctuation, duration becomes an unbroken line with no features to measure. You live at a moment when time feels dense, directional, and unavoidable. That feeling is not evidence of time's fundamentality. It is evidence of imbalance still at work. As that imbalance dissolves, time does not shatter. It simply stops being useful. What remains is not timelessness in a mystical sense. It is something quieter and more severe, a universe where time still exists in theory, but no longer applies to anything that matters. Consciousness requires heat, contrast, and flow. Thought depends on energy moving through structure. Memories require irreversible change. A universe without usable energy cannot host awareness. Not dead minds, no minds at all. You experience consciousness as something internal, detached, almost abstract, but it is not. Every thought you have is a physical process. Electrical signals move across membranes. Chemical gradients rise and fall. Heat is generated, exported, and dissipated. Awareness is not free. It is powered. A mind exists only because energy flows through an organized structure faster than that structure decays. Neurons maintain delicate imbalances in voltage. Synapses change their strength irreversibly. Information is written into matter by consuming energy and increasing entropy elsewhere. The very act of remembering requires that the universe become slightly more disordered. This is not incidental, it is essential. A reversible system cannot think. If every process could be undone without cost, no memory could persist. Consciousness requires that some changes cannot be rolled back. It requires friction. It requires loss. This ties awareness directly to temperature. Not comfort, but thermal availability. A system too hot cannot sustain structure. A system too cold cannot sustain flow. Minds exist only in a narrow thermodynamic window, where energy moves, but not too violently, where structure persists, but not too rigidly. As the universe cools, this window narrows. Energy gradients weaken, flows slow. Processes that once occurred naturally require increasingly precise conditions. Eventually, even the most efficient structures cannot maintain the throughput required for awareness. This does not mean minds shut off dramatically. There is no final thought, no last moment of clarity. Consciousness does not end like a signal being cut. It becomes impossible to initiate. Like a fire without fuel, not extinguished, but never ignited. The unsettling distinction is this. A dead mind implies something lost. A mind that can no longer exist implies something impossible. In a universe without usable energy, awareness is not absent. It is undefined. You cannot have a mind without time because thought unfolds. You cannot have time without entropy increase, because sequence requires irreversibility. You cannot have irreversibility without gradients, and you cannot have gradients in a universe that has exhausted them. This chain is unbroken. Consciousness is not a mysterious exception to thermodynamics. It is one of its most delicate products. It exists only because the universe is still far from equilibrium. The implication is not that consciousness is rare. It is that it is temporary, not because something destroys it, but because the conditions that allow it are transient. Awareness is a phase, not a feature. You may be tempted to imagine consciousness migrating elsewhere, adapting to colder, emptier conditions. But adaptation also requires energy. It requires change driven by difference. When difference disappears, adaptation stops. There is nowhere to go, because going requires flow. In the far future, the universe does not contain unconscious observers drifting in darkness. It contains no observers at all, not because minds were taken away, but because the universe no longer supports the processes that define a mind. This is not a philosophical claim, it is a physical one. Awareness is a pattern sustained by motion. When motion becomes inconsequential, patterns cannot persist. You are conscious now because the universe is still warm enough to allow it, because energy still flows unevenly, because time still accumulates change. None of these are guaranteed. Consciousness is not something the universe carries with it forever. It is something the universe briefly allows, while conditions permit, and those conditions are already fading. Cooling is not a prediction, it is a measurement. This is not speculative philosophy. It is what equations already describe. Every observation confirms the trend. The universe is not deciding to cool. It has no alternative. You might be tempted to hear everything described so far as a projection into an uncertain future, a story about what might happen if certain assumptions hold. But cosmic cooling is not an extrapolation layered on top of belief. It is a direct reading of what is already happening. When physicists describe the cooling of the universe, they are not guessing. They are measuring. They observe the redshift of distant galaxies. They measure the temperature of the cosmic background radiation. They track how energy density changes as space expands. Every one of these observations points in the same direction, not toward catastrophe, but toward dilution. The equations that govern this behavior are not controversial. They are the same equations that accurately predict stellar lifetimes, nuclear reactions, particle behavior, and orbital mechanics. They work because they describe how energy behaves in an expanding space. Cooling is not a separate hypothesis added on afterward. It is a consequence already built into the structure of the models. You can see this directly. The cosmic background radiation has a measurable temperature, and that temperature is lower than it was in the past. The distribution of galaxies shows that space is expanding. The light from distant objects arrives stretched in wavelength, carrying less energy than when it was emitted. These are not interpretations. They are data. Cooling is not something inferred from philosophy about endings. It is inferred from the present state of the universe compared to its past states. When you compare those states, the direction is unambiguous. Energy becomes less concentrated. Interactions become rarer. Gradients flatten. There is no parameter in the equations that allows this trend to reverse without introducing new physics that contradicts existing evidence. To stop cooling, the universe would need a mechanism to reconcentrate energy on large scales. No such mechanism has ever been observed. No experiment has hinted at one. Every test reinforces the opposite conclusion. This is why the universe is not described as choosing to cool. Choice implies alternatives. Physical laws do not negotiate. Given expansion, given conservation, Given entropy, there is only one thermodynamic direction available. The universe is not headed toward equilibrium because it prefers it. It is headed there because there is nowhere else to go. Even scenarios that propose new phases of physics do not escape this. They may alter rates, they may change timelines, but they do not eliminate the underlying trend. Cooling is not a model-dependent detail. It is a structural outcome of how energy and space interact. The unsettling aspect is not that scientists predict an ending. It is that the ending is already encoded in measurements you can perform today. You do not need to wait billions of years to confirm the direction. The evidence is already here. You are living inside a system whose trajectory has been measured, not imagined. The warmth you experience persists only because the process is slow, not because it is uncertain. Cooling is not a warning about the future. It is a description of the present. The universe is already doing exactly what the equations say it must do. The only unknown is not whether this trend continues, but how long it takes for its consequences to become unavoidable. And on that point, the universe offers no reassurance. The future is not catastrophic. It is indifferent. There is no final moment, no cosmic failure, just an asymptotic slide into sameness. An ending so gentle it almost avoids being called an ending. You are conditioned to imagine endings as events, explosions, collapses, a last instant where something breaks and everything after is different. But the future implied by a cooling universe does not provide that kind of punctuation. It offers no climax, no moment where the universe visibly gives up. It simply continues, changing less and less each time it changes at all. Indifference is harder to confront than destruction. A catastrophe has a shape. It announces itself. It creates contrast between before and after. Indifference does none of this. It erodes distinction quietly, without demanding attention. Nothing fails. Nothing resists. Nothing needs to be repaired. In this future, the universe does not end its activity. It loses interest in outcomes. Processes still occur, but they no longer lead anywhere. Events no longer accumulate into consequences. The universe does not become hostile to structure. It becomes neutral toward it. This neutrality is the defining feature of thermodynamic equilibrium. When everything is equally likely, nothing is favored. When no state is privileged, nothing stands out. The universe does not prevent complexity. It simply stops supporting it. This is why there is no final moment to mark. No boundary you could point to and say, this is where the universe stopped. Every step towards sameness is smaller than the last. Every remaining gradient weakens asymptotically, approaching zero without ever quite reaching it in finite time. From inside this process, nothing dramatic happens. There is no sensation of loss. There is only less contrast, less novelty, less reason for anything to occur rather than not occur. The universe does not go dark. It goes quiet. This quiet is not empty. Matter remains. Energy remains. Space continues to exist. But the relationships that once gave these things significance flatten out. Everything that remains does so without urgency or direction. You might expect such a future to feel tragic. But tragedy requires awareness. It requires an observer who can compare what is with what was. In an indifferent universe, even that comparison fades. Not because memory is erased, but because memory can no longer be formed. The unsettling implication is that the universe does not oppose meaning. It simply does not preserve it. Meaning exists only while differences exist that can support it. When those differences fade, Meaning does not collapse, it evaporates. This future is not cruel. Cruelty implies intent. It is not unfair. Fairness implies judgment. It is not even final in a strict sense. It is endless continuation without consequence. You live in a universe that still reacts, that still amplifies differences into experiences, structures, histories. That reactivity is not permanent. It is a transient phase in a much longer drift toward neutrality. The future does not arrive as a disaster. It arrives as a diminishing return on change itself. Each new moment becomes less distinct than the last until distinction ceases to matter. An ending that does not announce itself. A conclusion without a closing line. A universe that does not stop, but no longer has anywhere to go. Your present exists only because the process is incomplete. The warmth in your body is borrowed time. The light in your room is delayed history. Every experience you have depends on gradients that are already shrinking. You live inside a narrowing window. Nothing you perceive as immediate is truly happening now. The light that reaches your eyes began its journey moments ago. The heat in your body is the result of chemical reactions initiated in the recent past. Even your thoughts lag behind the physical processes that generate them. Your present is a thin slice carved out of ongoing transitions that began before you noticed them. This delay is not a flaw in perception. It is a requirement for experience. To feel warmth, energy must flow. To see light, photons must travel. To remember, physical states must change irreversibly. Each of these requires gradients that have not yet flattened. Each depends on the universe still being unfinished. Your body maintains itself by staying out of balance. Blood flows because pressure differences exist. Cells function because chemical concentrations differ across membranes. Your brain operates because electrical potentials are constantly created and dissipated. None of this is stable. It persists only as long as energy keeps moving from where it is concentrated to where it is not. This is why your present is fragile in a way that feels counterintuitive. It does not rest on permanence. It rests on ongoing loss. Every moment of awareness requires the universe to give something up. Heat must be exported. Order must be paid for with disorder elsewhere. Your existence is powered by the same process that guarantees it cannot last forever. You do not notice this because the gradients that sustain you change slowly compared to your lifespan. The sun continues to shine. The earth continues to radiate heat. Chemical fuels remain abundant enough to support metabolism. From your perspective, these conditions feel fixed. But on cosmic timescales, they are transient states already sliding toward exhaustion. The unsettling truth is that nothing about your present is guaranteed by the structure of reality itself. It is guaranteed only by timing. You exist after the universe has cooled enough to allow structure, but before it has cooled enough to prevent it. That interval is not centered around you. It is indifferent to you. You simply happen to be inside it. This reframes what it means to be alive now. You are not standing at the peak of a stable world. You are passing through a corridor. Behind you lies a universe too hot for complexity. Ahead of you lies a universe too cold to support it. Your present is not the default state of things. It is a brief alignment of conditions. Even the solidity you rely on is temporary. Atoms hold together because energy levels remain within narrow bounds. Molecules persist because temperatures are neither too high nor too low. These constraints are not eternal. They are maintained by a balance that is already drifting. When you consider the future of the universe, it is tempting to imagine that what exists now will simply continue until something dramatic intervenes. But nothing needs to intervene. The same process that allowed your present to emerge is slowly withdrawing its support. No catastrophe is required, no external force, just time. This means that your experiences are not merely happening against the background of cosmic cooling. They are expressions of it. Every perception you have is made possible by the remaining unevenness in the universe. Every second that passes reduces that unevenness slightly. The narrowing window you inhabit does not feel narrow because your reference point is limited. You measure life against human timescales, not cosmic ones. Against those larger scales, your entire civilization exists as a brief fluctuation, sustained by gradients that will not be replenished. This does not make your present meaningless. It makes it conditional. Meaning exists because conditions still allow it. Awareness exists because flow has not yet stopped. Time feels rich because change still accumulates. You are not living at the beginning of the universe's story, nor at its end. You are living during the only kind of chapter where experience is possible at all. The warmth you feel is not yours to keep. The light you see is already fading. The present you inhabit exists only because the universe has not yet finished becoming what it is moving toward. And that incompleteness is everything. The universe is not dying. It is finishing. Death implies violence or loss. This is neither. It is completion, a system reaching its most probable state. Not broken, not destroyed, just done. You are inclined to describe endings in emotional terms. Death feels abrupt. It feels like something being taken away. But the future implied by thermodynamics does not resemble an injury or a collapse. Nothing is removed. Nothing is damaged. What happens is quieter and more absolute. The universe is not failing to sustain itself. It is succeeding at doing exactly what its structure makes most likely. In statistical terms, systems move toward the states that can be realized in the greatest number of ways. High entropy is not a mistake. It is not decay in the moral sense. It is probability expressing itself over time. When energy is evenly distributed, there are vastly more microscopic arrangements that produce that condition than arrangements that preserve contrast. Uniformity is not imposed. It is selected. This reframes the end state entirely. The universe does not arrive at equilibrium because something went wrong early on. It arrives there because equilibrium is overwhelmingly favored. Every star that burns, every gradient that flattens, every structure that dissipates is part of that movement toward what is statistically inevitable. Nothing resists because nothing needs to. There is no opposing force pulling the universe toward complexity. Complexity emerges temporarily when conditions allow it, but it is not the destination. It is a passage. This is why the end is not dramatic. Violence requires opposition. Loss requires something to be taken from somewhere else. Here, there is neither. Energy remains. Matter remains. Space remains. What changes is the distribution. Difference fades not because it is attacked, but because it is improbable to maintain. In this sense, the universe is not dying. Dying implies interruption, a life cut short, a process halted before its natural conclusion. What is happening here is the opposite. The universe is completing the trajectory it began in its earliest moments, when it existed far from equilibrium. Everything that followed, the formation of atoms, stars, galaxies, planets, life and awareness, was part of that trajectory. not a deviation from it. These were intermediate configurations made possible by an initial imbalance. Once that imbalance is spent, nothing compels the universe to remain interesting. Completion does not look like emptiness. It looks like sufficiency, a state where nothing further is required because nothing further is likely. The universe reaches a condition where all macroscopic distinctions have been erased, not by force, but by repetition. From within that future, there is no sense of loss. Loss requires memory. It requires comparison. It requires a before and an after that matter. In a finished universe, those distinctions no longer function. The universe does not mourn itself. It does not notice that anything is missing. This is difficult to accept because you experience yourself as unfinished. Your life is oriented toward continuation, growth, and preservation. You project that orientation onto the universe and expect it to share your resistance to finality. But the universe does not preserve, it transitions. The unsettling implication is that meaning, as you understand it, is not something the universe protects. Meaning arises when conditions allow contrast, memory, and consequence. When those conditions fade, meaning does not collapse. It simply stops being generated. Nothing is ruined by this. There is no wreckage, no aftermath, just a system settling into the state it was always moving toward, long before there were observers to name it. You are not watching a universe on the brink of death. You are living inside a universe approaching completion, not an ending marked by catastrophe, not a failure of design. Just the quiet fulfillment of probability, playing out over unimaginable time. The universe does not break, it finishes.